Yeah, uh, it is a theorem. If a function f is differentiable, uh, they are taking a function f. In general, it is. They are not telling this function like x cube or x square plus 2 or x cube plus 2x plus 3. So these functions I said, right, x square, x cube plus 2, these are particular examples, but they are not giving any functions like that. They are just telling some function. In general, they are telling some function f. Okay, that function is differentiable. Differentiable means we can differentiate that function, we can find derivative, like that. It's the meaning. At a point c, at a point, first I will draw a graph. So this is x-axis, this is y-axis, 0, 1, 2, 3, like that. Here also some values will be there. X-axis, y-axis. They are telling some function f. In general, they are telling I will take a function in general. Like for example, the function is like this. This is function. F is differentiable at a point C. Point C means this is x-axis, right? For example, here some value C. So x is equal to C. Okay. So this is x is equal to 1, x is equal to 2, and here x is equal to 3. Here some point. So we don't know that number. So I am just taking general. So x is equal to c. At this point, at x is equal to c, c is some value. So corresponds to this, you draw one dotted line, vertical line here, like, okay. So corresponding to x is equal to c. So here we get the point. Here some value will be there, that is function value. Okay. So they are telling this function f, this is f function, is differentiable. We can differentiate at x is equal to c. Here at x is equal to c, the corresponding function value is this. Here will be some value, like here we'll get something like 1, 2, this is 3. Here some value will be there. Okay. So on y-axis, here some value will be there. So when you put dotted line, here you will get some value. So this value will be this value. Okay. So this is a general graph I have written. They're telling it is differentiable at point C, then it also continuous at that point. Continuous means there is no any break. See, if I erase here, see there is open, there is some break, right? Function is not continuous. See, if I draw like this, it is continuous. When I erase here, there is a open. So they are telling we have to prove it is continuous at that point. That means at that point means here at x is equal to c, here this is, here function is continuous. I mean there is no break like this. There is no break like this. The function is continuous like this. So that we have to show. Okay. Okay. So theorem states when this function f is differentiable at x is equal to c, then at x is equal to c the function is continuous. That means there is no break, any break here. That's what theorem are telling. So we have to prove this theorem, we have to show this theorem is correct. So for that, see, first point, consider this function f is differentiable at point C. So I will write, so since, okay, since f is differentiable, right, f is differentiable at C. At C we have, so theorem telling here, it states function is f is differentiable. Using this we have to prove this it is also continuous. We have to prove the function is continuous at that point, I mean at x is equal to C, using this statement, this part. The first part is function f is differentiable at a point C. We have to use this to prove the function is continuous at that point. Okay, in the beginning you just understand this much. When we complete the theorem solution, you will understand better. Okay, now this part, so function f is differentiable, they are telling at a point C. So when f is differentiable at point C, we can write a formula. We have a formula, we can write like this: limit as x tends to C, okay, f of x minus f of C, x minus C, that is equal to f dash of C. So this you have to remember. Okay, when f is differentiable at point C, this is the formula we have to use. This we have to remember. Next, using this we have to prove the function is continuous. So I will just erase this top part. So any previous content if you want to see, you can just move the video backward. Okay, so this is at point C. That means as x tends to C, what happens? Okay, for example, if x is not equal to C, when x is not equal to C, then the function will become f of x minus f of C. See, when x is equal to not C means we won't consider this part. See, so the function is f of x, right? F of x. At x is equal to C, we have to substitute this in place of x, we have to substitute C. It will become f of C. Correct? So that means at x is equal to C, this point, so this point is f of C. F of C. Okay, so when x is not equal to C, that means when x is not C, there is no C value, definitely f of C won't be there, because I am telling x is not equal to C. That time what happens, this is whole function, this curve, the entire thing is f of x. So they are telling when x is not equal to C, f of C is not there. Now we have to subtract this f of C from f of x. So that's why I have written at x is equal to C. Sorry, when x is not equal to C, then we have to subtract this f of C from this function. So I have written f of x minus f of c. Okay. Now this, so this can be written as, this can be written like this: f of x minus f of c whole divided by x minus c into x minus c. This dot is into, it's like multiplication. See, this can be written like this because see x minus c will cancel out. Okay, when x minus c cancels out, we get same thing, f of x minus f of c. Here also f of x minus f of c. F of x minus f of c is equal to this f of x minus f of c. LHS is equal to RHS because this and this cancels out. So I can write f of x minus f of c is equal to like this. Because if this and this cancels, we'll get same thing back, f of x minus f of c, this one. Okay. So now I will continue from here. Yeah, because of space issue, I will just erase this. Yeah, after sometimes I will get the new board. I will purchase a long board. So as of now, I am just erasing any previous content. If you want to see, please move the video backward. Now we have this, right? So when x is not equal to c, we have this formula. Now take limit on both sides. First for this, limit, what limit? As x tends to c. Limit as x tends to c, this one, write it here. F of x minus f of c is equal to, again, same limit you take here also. Limit x tends to c, this whole thing you write here. F of x minus f of c whole divided by x minus c into x minus c. So in the next step, here minus is there. You can take this limit separately for this and this separately. First, limit x tend to c, this one, f of x. This minus, again, limit x tend to c, this f of c. This equal sign. Here also, your into is there, multiplication is there. So you can take this limit for this thing separately, then for this separately. So first write this limit as x tend to c, this one, f of x minus f of c whole divided by x minus c. Next into is there, put that into. Again take limit for this. So I will take this limit x tends to c, this one, x minus c. I hope you understood till here. Next step is what? So write this as it is. Before that, see, limit is there, this is f of c, here also c, and here also c, correct? Here also c, and function f is differentiable, so this you can take 0. So when this becomes 0, you write only this part. Limit of this f of x as x tends to c equal to Next here, see limit of this. In the beginning I shown, right, limit of this by limit of f of x minus f of c divided by x minus c as x tends to c is equal to f dash of c. In the beginning I put a box and I told you to remember. Okay, so just move the video backward, you will see that. So this thing can be written like this. This is equal to f dash of c, next into dot in the middle at the center. If you put, it will become multiplication, and this one. So limit of x minus c as x tends to c. So first write this limit. Write this x. No, not limit. No. So x minus c you have to write. No, not x minus c. Limit of x minus c as x tends to c. That means in place of x you have to substitute c. So in place of x I will substitute c minus this c. Now next step, write this f dash of c into c minus c is 0. Correct. Now that is equal to, so anything multiplied with 0 will get 0 only. So we got, write this. So equal to sign should be here. Okay, because this is limit x tends to c. At x tends to c you should not put equal sign. Okay, here you have to write. Just because of space you see I have just written here, but while writing exam you write equal sign here somewhere. It should not, this equal sign should not be here, mean corresponding to this x tends to c. It will become wrong. So you should take care of that. As of now I will just put equal sign here. So next write this limit f of x as x tends to c is equal to this 0. See what they have given, function f is differentiable, right? So function f is differentiable. F means f of x. First I'll write f of x. F or your f or f of x both are same. They are telling function is differentiable. This function f of x differentiable at x is equal to c. That means if you put at x is equal to c, in place of x if you substitute c, we get f of c. Correct? We get f of c. See, since this c is a constant, this c is a constant, and f of c will become a constant. Okay, when we differentiate constant it will become 0. Okay, it will become 0, and in place of 0 we can write this f of c. Now see this limit of f of x as x tends to c is equal to f of c. That means in place of x, if you substitute c, we get f of c. That means what? F of c is a value. I have shown in a graph, right? I will just erase. I have shown in the beginning is a graph like this. This is x-axis, this is y-axis. At x is equal to c, this is f of c. So this point is c, this point is f of c. F of c means it's a value, constant value, y value. It's a value, constant. value. See, this equation states when you substitute c in place of x, we will get f of c. F of c is a value. There is some value. Okay. So when x is equal to c, we get a value for f of c. So here there is a value. So there is a function value for x is equal to c. That means the function is continuous. Okay. The function is continuous like this. The continuous means there is no break here. There is no any open, there is no any break here. There is no any opens here. It is continuous. Because at x is equal to c, we have a value. We have a value for f of c. We have a value f of c here. So that is what it is telling. This equation is telling. At x is equal to c, there is a value. So when there is a value for x is equal to c, that means the function is continuous. Okay. So we have proved the theorem. That's all. We have to prove that only. If the function f is differentiable, then we have to show that function is continuous at point x is equal to c. So we proved this equation tells this function f of x is continuous at point c when the function is differentiable at point c. Okay, so that is done. Thank you. Subscribe.